Hi students, these are the instructions on how to determine if an equation is balanced or not. Quick review of what you learned in class. First of all, you learned how to count atoms, and counting atoms involves looking at the subscript. You should be thinking of the little rhyme. Subscript, parentheses, coefficient. Okay, and whatever those numbers are, for the subscript, parentheses, and coefficient, you multiply the three together and get your counting atoms. Let me just give you an example of this. Okay, this is a phosphate. Really, there are 4 molecules of phosphate because this is the coefficient, which tells us how many molecules there are of this particular compound. PO4, the 4 is a subscript, the 3 is a subscript outside of parentheses. So quick review here, we have 2 elements involved. We have phosphorus and we have oxygen. And remember the little saying, subscript, parentheses, coefficient. So you're going to go to phosphorus. There is no subscript, so it's automatically a 1. After subscript, you go to the parentheses. There are parentheses that it's inside. So you multiply it times the 3, and then times the coefficient out front for a total of 12 atoms of phosphorus. Our oxygen would end up being 4 times 3 is 12, times 4 is 48. That's just counting atoms. Another thing you learned is that there is a law in nature called the law of conservation of mass, and that during a chemical reaction, no atoms are lost and no atoms are gained. So when we write out a chemical equation, which is our shorthand method of writing what happens in a chemical reaction, when we write that chemical equation, we have to make sure we write it correctly so that it matches what really happens in nature. So if we were to have some hydrogen gas and some oxygen gas and they produce water, okay, you're going to start off by noticing that your arrow is your division between your reactants. Your reactants come before the arrow in the equation, and your products. You're always going to be comparing the number of atoms of each element on both sides, okay, before the arrow and after the arrow. The easiest way to do this, I've always thought this was an easy way to do it if you have room, put a line right below your arrow so that you can divide your reactants from your products. The elements involved are hydrogen and oxygen. And what I do is I'll look here on the reactant side. It says we're starting off with 2 hydrogens and 2 oxygens. On the product side, the way it's currently written, H2, there are 2 hydrogens, and look here, only 1 oxygen. This is saying that we started with 2 hydrogens, ended with 2 hydrogens after the reaction. We started with 2 oxygens and ended with 1. That is not true. Because of the law of conservation of mass, there is absolutely no way that 1 atom was lost. So, evidently, our equation is not written correctly. Okay? Now, for your purposes, all you have to be able to do is identify whether this equation is balanced or not. Noticing here, your differences in your oxygen on your reactant and product side tells you without a doubt this is not balanced. Now, for those of you who are wanting to know, well, how in the world would we balance this? It's not too difficult on this particular type of an equation. It can get a little bit hairy on some of the more complicated ones. But what we would have to do is make sure, now we can't go dropping this oxygen to 1. Okay, because O2 is a diatomic element. It's going to come in pairs. So we can't just change that to 1. By the way, if you are balancing equations, you can never change the subscripts. Never. Okay? All you can do is change the number of molecules they have of each one. So this is saying I ended on the product side with 1 oxygen, but if I put a 2 coefficient out front there, okay, then I have 2 H2O molecules. So I now have 2 oxygens. What I have to be careful with, though, is that when I put a coefficient, it's usually going to mess up something else, which isn't that big of a deal. 2 times 2, the way this is written now, says we ended with 4 hydrogens. Is it balanced? Is the equation balanced now? The way it's written now with this coefficient of 2 here in front of the water, it's saying we started with 2 hydrogens and ended with 4. There's no way. That cannot happen. Evidently, this equation is not telling the correct story of how this reaction happened. So what we need to do is start looking at what we can do, to make this balanced. Hydrogen, there are 2 before the parentheses. What if a coefficient of 2? What if there were really 2 H2 molecules? Let's see if that works. 2 times 2, we've now started, the way it's written says we've started with 4 hydrogens. Let's double check ourselves. 2 times 2, 4 hydrogens. Here we have 2 oxygens. Okay, that's on our reactant side. On our product side, we have 2 times 2, 4 hydrogens. 2 times understood 1 is 2 oxygens. Let's compare. The way the equation is written now says that we started with 4 hydrogen atoms and ended with 4 hydrogen atoms. Started with 2 oxygens and ended with 2 oxygens. Guys, this is a balanced equation now. What that means is that when hydrogen and oxygen come together to make water, it has to come together this way. There must be 2 H2 molecules available and 1 O2 molecule. After the reaction occurs, you then have 2 H2O molecules. I'm going to quickly show you a picture of this. Whoops, there we go. All right, let's say this is a hydrogen and a hydrogen. Okay, that's an H2 molecule. Okay, oxygen, O2. Here's an oxygen, here's an oxygen. Okay, now, the way that we ended up with this being balanced was that we needed 2 of these H2s. So let's draw another one. Okay, so we now have 2 H2s plus 1 O2 produces. It said we had 2 H2Os. So I'm going to draw 1 H2O. H2, here are 2 H's, and the O, the oxygen. But it said that we had not just 1 of them, but 2. OX for oxygen, HH. A lot of people draw these and say, oh my gosh, the H2O looks like a Mickey Mouse. Yes, it kind of does. But let's count these. Let's go ahead and count these. We have 1, 2, 3, 4 hydrogens on the reactant side. Well, how do we know what the reactant side is? Before the arrow. So we had 4 hydrogens on the reactant side. 1, 2, 3, 4 on the product side. 1, 2 oxygen atoms on the reactant side. 1, 2 oxygens on the product side. Okay, basically all that happened, this is a chemical reaction and the atoms rearranged. All right, going to your homework on page 67, we'll help you with the first one here. There is an example at the top, but I'll go ahead and help you with this first one. We'll have to do it quickly. The time's about to run out. The elements, sorry, let's go to the second one. We've already done that one. There is phosphorus, P, and O. On the reactant side, we have 4P and 4O on the product side. 5 times 2 is 10 oxygen. 10 here Yes, it's balanced. Time's up. Video ends.